is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
Hello and welcome to SkyTour Radio here on KGRAradio.com. But you knew that already. I'm your host, Mark D'Antonio, here with my effervescent and always enjoyable Amanda Curran. Hi, Amanda. How are you?
I'm well, Mark. How are you?
I'm good, and I do believe Daryl Mason is joining us once again. Daryl, you're becoming a fixture on SkyTour Radio. How does that make you feel?
Like it or not, I guess. Hi, everybody.
Like it
Hi,
or not,
Daryl.
I guess.
Hi, Amanda.
Well, we love it.
Yeah. Actually, there's positive feedback for Daryl's appearances on the show, and we actually like it as well. He's a good friend, and he is a very knowledgeable guy, even though he'll say, when you tell him that. Exactly. But that's okay. That's as we say it this way. That's our Daryl. So, yeah, see, that's all good. Now, so I want to welcome you guys, the KGRA listeners, the finest listening audience on this planet, to this broadcast. It is the broadcast for July 14th. It's a live broadcast, of course. We're not doing replays at the moment. We had to in the past, but we're doing none of those right now. So I want to offer up to you that if you are avid listeners of SkyTour Radio, then you can also become avid viewers of SkyTour Livestream. What is that? Well, SkyTour Livestream is a clear night journey on clear nights, of course, into the wonders of the deep sky, and it's all courtesy of this wonderful research-grade telescope that we have here at the John Zach Memorial Observatory here in northwestern Connecticut. You can see all kinds of stellar objects, where stars are born, where stars died, the debris they leave behind, the influence they have on other areas in space where very powerful stellar winds blow gas around. You can actually see all this. And you can also see, after they've blown all that gas away, you can see the remaining glittering jewel boxes, which are the clusters of stars. There are millions and millions of clusters in the night sky. So, I kind of picked the right profession, didn't I? Because I'll never run out of things to see. Ever. There's always new things to see. For instance, when we looked at dying star remnants, we've seen something called the Ring Nebula. It looks like a smoke ring in the sky. But something I have never seen, and it's actually not too far away from this particular Ring Nebula, is something called the Little Ring Nebula. And I was like, well, wait, Little Ring Nebula. And Daryl was with us on one of these Sky Tours.
I remember seeing that.
And I was going to say, and Amanda was with us.
Me too.
Yeah, we're going to go around here. And we actually saw another Little Ring Nebula a little farther away. It was kind of interesting. Now, I'm an astronomer, and astronomers don't necessarily know everything about the night sky in terms of where things are in the night sky. In fact, many of the people that I knew and professors I had through college and so forth, and even in grad school, the professors I had many times didn't know everything about the subject that they were purported to know the most about. There was always gaps in their knowledge. One of my astronomy professors, for instance, he couldn't go outside and tell you where the North Star was. Yet he was one of the most prolific finders of new stars in the entire universe. Well, as far as we know, because we only know Earth. But he was one of the most prolific finders of new young stars on Earth. And he's been all over the world searching for them. Yet when he goes outside at night, he looks up and says, where's the Big Dipper? I got to find the North Star. It's like, wow. It kind of makes you realize what happens when you focus so much on your science that you forget about the practical side of astronomy. But that's okay. That's okay. I've chosen to do the outreach side of astronomy with my degree, and that's why I'm going like this with astronomy. That's why Amanda's my co-host on SkyTour Livestream, because she's a wonderful offset. Daryl's amazing to bring on board with us too. And so together we all tend to give the people that watch SkyTour live stream and the people that listen to SkyTour radio a wonderful evening. With in SkyTour live stream's case, some really nice views, and in SkyTour radio's case, some really cool information. Tonight won't be any different. Now, if you're interested in getting more or looking up more about what we do, you can go and check out our 3D printed Moon, Mars, and Pluto landscapes, as well as craters. These are taken directly from the NASA data, and I've spoken directly and worked directly with the curators on getting this data, helping them improve their project. And it's really cool, and these are little plates you can get that are 3D printed right here at FX Models, my company. But we make them, and basically we sell them pretty much at cost. We're really not making any money on these, and that's okay. We don't need to. We want to this is part of astronomy outreach. We want to reach out and show people, what does a moon crater really look like? I mean, you see it flat when you look up at the moon. You see a shadow. But having it in front of you and being able to take it like a pen light and move it around on there and see how the shadows fall, it gives you a much better feel for how that works. We're also interested in taking our 3D craters to help out people that have impairments like sight. If you can't see, but you want to know what a crater feels like, you can take this in your hands and run it through your fingers and feel the texture of the craters. It's like astronomy braille in a sense. And so that's a project that we're also working on. So SkyTour Livestream has a lot of things that it involves itself in. So hopefully you'll join us on YouTube. It's clear nights only, of course, but we also do cloudy night streams. And Amanda, you've been there for some of them, and Daryl maybe even has been there for a couple of them.
Oh, yeah.
Yeah. And sometimes we use Universe Sandbox 2, the successor to Universe Sandbox, a very successful simulator that shows all the physics of the solar system. And we launch things like big asteroids at other planets. We launch an Earth at Jupiter and watch how Jupiter just swallows it up and that's it. It's like, wow, that's what would happen, huh? Well, Jupiter heats up tremendously and it gets very red hot for a while, but then it actually goes back to being normal again. So pretty interesting. So if you're interested in contacting us or talking to us or asking us questions, you can always reach us at SkyTour Radio at kgraradio.com. And we'll be happy to help you. That's SkyTour Radio at kgraradio.com. Also, we have a call-in number, which we'll give you a little bit later. And in the last half hour of the show, the lines will be open. That number is 85-KGRA-LIVE. Or for those of us that hate looking at the phone dial to try and figure that out, 855-472-5483. We'll give you that number a little bit later, too, but it's 855-472-5483. Now, what are we doing tonight? You guys have any idea what we're doing tonight, Daryl? How about you, Amanda?
I heard a rumor.
You did, huh?
I did.
Mm-hmm.
For anyone that may have tuned into oh my god, I totally blanked on his name. I was thinking Mark Center, but Don Ecker, yeah. I was thinking Mark Center for some reason, but it was Don Ecker's show last night.
Yeah, well, Mark Center there.
Yeah, I heard a little bit of it, and we're going to be exploring more volcanic activity.
Well, you're exactly right. We're going to be talking about some interesting things that could kill a planet.
And other things that can kill planets besides volcanoes.
Maybe we'll talk about things falling on our heads.
Ooh, Mr. Clever. You're exactly right. Of course. And you see,
Should I be looking up lately?
Oh, I hope not. Because that'd be pretty dangerous.
On my head.
Yeah, no. Well, actually, if something was going to fall on your head, it'd go right through the roof of your house anyway. It's moving pretty quickly, so you wouldn't be able to be protected from it unless you're several floors down. You're in the basement though, so you might survive it. Although there was a woman just a few miles from here, in the city or town of Wethersfield, Connecticut, and she was sitting watching TV. You can't make this stuff up, folks. And she heard a loud bang. And from the bottom of the floor, up through the floor, from the basement, this rock came up and struck her in the hip. But it came up from below. And she had no idea what had happened until they saw the hole in the roof. What had happened was this meteor struck, went through the roof, went through the first and second floor of the house, down into the basement, bounced off the concrete, came up through the floor, and struck her sitting on the couch.
Jeez.
She should have bought a lottery ticket right then and there.
Wow.
Yeah. And then get this. 2 years later, approximately 2 years later, I think, another meteor struck in the town. I couldn't believe it. And this time it actually it struck a car, and it struck the trunk, and it just peened the trunk right down, like it pulled it in like aluminum foil, and went right through everything down into the driveway. And when the guy saw the car, he thought that maybe some vandals had done this to the car, until he saw the rock embedded in the driveway. It turned out that he had been struck by a meteorite.
Yep.
That man also should have bought a lottery ticket right then and there.
Yep. It was a Chevy Citation, if I remember correctly.
See that? Daryl's on top of things. He remembers these things,
Oh, yeah.
Yeah. And for those of you in Skytour Livestream, you've seen my meteorite I have here. I have one from an Argentinian fall. I think it was, it's like there's a famous Argentinian fall.
Cielo something or other?
Yes. That's the one. Yeah, Cielo. And it's actually about 1,000 grams, so it's solid iron. So it's pretty heavy. 1,000 grams is pretty hefty, and it's actually just over 1,000 grams. So it's pretty cool. And you can imagine those things falling. Now, when they enter the Earth's atmosphere, they hit the atmosphere and they begin to slow down. Okay, and all this relates to tonight's topic, by the way. They start to slow down, and when they start to slow down, the wind resistance picks up on them more and more and more. And if they're very big, then they reach a certain point where there reaches a maximum aerodynamic pressure on this rock coming into the atmosphere, and it's a breaking point. And beyond that, the meteor can't stay in one piece. It breaks apart from the pressure because it's a very irregularly shaped thing anyway. It's not coming in round. It's irregularly shaped, and it's usually tumbling. So as the different parts of this meteor hit the different densities of the atmosphere, as it's tumbling into the atmosphere, it might tend to weather vane a little bit, and that's gonna, at the point where it starts to do that, the atmosphere has to be pretty thick, and by that point the meteor is heating up quite a lot, and parts are already coming off of it for sure. It's certainly leaving a smoke trail of burning debris that is being what's called ablated. That's ABLATED, ablated off of the meteor, and falling behind in the path, which will then fall to Earth. But then it'll reach a point where it can't stay together anymore. The pressures are too much, and it will explode. And this will become something called an airburst. And when that happens, because of the speed of the meteor entering the atmosphere, and sometimes they come in at like between 20 and 40 kilometers per second when they strike the atmosphere. You can imagine that's pretty fast. So when they do that, yeah?
Oh, no, sorry, I thought you were done. A few questions are coming in.
Oh, okay, good. But let's finish this piece and we'll go for that. Thank you. Amanda, as always, right on top of things. Thank you very much. I love my co-host, and Daryl's just very clever. He has a lot of really cool things to say. I feel like I'm surrounded by greatness here, and Anyway, there it is, folks. Oh. So that said, when the meteor explodes, that creates a shock wave. Now, in space, if it was to explode for one reason or another, it would mean it would have to hit something that would break it apart. But in the atmosphere, it's the air molecules striking it and the friction and so forth that causes these aerodynamic pressures that'll break it apart. Air is a medium and can transfer shock, sound waves. So when this thing breaks apart, because it has so much energy from being so fast when it hits the atmosphere, when it blows apart, that shock wave radiates away in all directions. And when it reaches the ground, it could be anywhere from a few seconds to a few minutes when it reaches the ground. Likely a few minutes. But when it does reach the ground, it's a very powerful directed shock wave that's coming down from all directions. And so if you are in a building near a window and you watch this meteor go over and you watch it explode, first thing you should do is get behind something solid, because when that shockwave hits, it's going to blow that window out. And that's exactly what happened with the Chelyabinsk meteor that occurred some years ago. And that meteor, that actually blew open steel security doors and bent them in half. Made them into V shapes. I watched it happen, not there, but on the security cam video. Luckily, the Russians always have dash cams and security cam video galore. And so there was a lot of evidence, a lot of this. And you can actually see when it entered the atmosphere. And we're just talking about a small meteor, by the way, guys. This meteor comes in. You actually see the brightness of the meteor was so much that it overpowered the brightness of the setting sun or the early morning sun. I forget, Daryl, do you remember if this was a morning or afternoon?
Morning.
Was it Chelyabinsk was morning?
I believe it was, yes.
And you could see it was sort of like the sun was still low on the horizon, and the meteor came through, and you actually saw these extremely bright shadows, or bright light that was creating these bright shadows on the ground and on building edges and so forth. And that was the meteor reaching that point of maximum capability to withstand the air. And then when it blew up, that's when the shockwave started down to the ground. And the security cam footage shows doors busting open. You can see windows blowing out. And that was from a tiny, a relatively small meteor, which is only a few feet across, actually. And this, so the question we ask is, how big does something like that have to be to kill our planet? And so this is, believe it or not, this is our exoplanet roundup for tonight. We're actually talking about this, our special report. Last week we talked about volcanic upheaval and how in Siberia, in the Siberian Traps region, a flood basalt where a fissure opened up and basalt came out, made a giant lava cap over many square miles of ground. And that was blocking the rest of the magma from coming up, if you recall. And that magma underground went around the perimeter. It went, squeezing out from the center to the outside, radially away from the center of this vent. And it reached other compounds in the soils, which released a lot of carbon dioxide. And that was pushed forward. And when it finally reached the end of that lava cap, if you recall, the magma burst forth, and so did many, many gigatons, billions of tons of carbon dioxide. So talk about instant global warming. And overall, if you remember, the Earth heated up to 27 degrees hotter, and a lot of methane was released. Methane is far more efficient as a greenhouse gas than carbon dioxide. And the methane release was because of the methane ices that were previously frozen in the sea. The sea heated up so much that those methane ices melted. Methane was freed, came to the surface, bubbled up into the atmosphere, and took on the role of greenhouse gas as it's wont to do. And that started that cascade of life dying off. Warm oceans don't like to hold a lot of oxygen, so the oxygen depletion killed off a lot of animals. Reefs died in the heat when the heat exchanged, and then the creatures that give us oxygen, for instance, so the phytoplankton. Phytoplankton were killed. And so a lot of changes took place, and it took a long time. But you see, it's a domino effect. It's a domino effect. When one thing goes bad like that, you might say, well, this eruption didn't have a whole lot of, there were there were animals on the other side of the planet that didn't even know this happened. So how come they were affected too? Well, it was because of the overall global warming that occurred, because of the cap of magma that kept the lid for a period of time on the rest of the magma trying to get out. And of course, the carbon dioxide that went with the magma, that spelled the end. And that was the biggest problem. On and off for about 300 years, remember, that this eruption took place. The main eruption was about 100 years long. So if you can imagine. So that's the Earth-based way in which the planet could be killed. And so I guess when we talk about other ways, we think what you all think, and we talked about the Chelyabinsk meteor. Well, what about an asteroid? Different size asteroids have struck this planet. Many have, actually.
And comets.
And comets as well. Tunguska may have been a comet. The Tunguska explosion was an airburst again. The bigger objects, unless they're on a really interesting trajectory, let's put it that way, unless they're on a specific trajectory, they're not going to make it all the way to the ground typically. They're going to blow up, and that's going to be something that's going to work for us, work against us. And it works for us in that it doesn't allow a large object to get to the ground where it can blow a big hole and throw lots and lots of dust up into the atmosphere. Okay. However, and then of course that would block sunlight and cause, lack of summer for a couple of seasons or whatever, and kill plants and so forth. But the Earth has a way of dealing with these things, and by the way, so do humans. And I say that because I wanted to make sure you understood that we are tracking these asteroids that could potentially be bad for us. Asteroids are bad for your health, folks. They really are. We have right now there's 22 candidates in what's called the Sentry database, and if you look up the Sentry database, you'll find that there are a number of potential impactors that we're watching that are near Earth asteroids. And you'll see that not many of them have really, interesting names. The only one that you'll recognize is probably Bennu, Bennu. And it has potential impacts. It has 78 chances to hit the Earth. Okay. However, you say, "Oh, wow, that's really high probability. 78 chances. Holy cow!" Yeah, except each chance is way less than 1 out of 100%. Okay, so we're talking about something that's like 10 to the minus 4, so that's like 0.0001 kind of a mathematics. So that's the kind of chance it is for something like that to hit, and that projected hit is somewhere around the year 2175 to 2199 when that could happen. So there's nothing nearby that could really do serious damage to us. Some of these are most of these are actually under a kilometer in size. All right. The only one that's bigger than that is 29075 1950 DA. What does that mean? Well, it has one possible impact, and again, it's a 10 to the minus 4 type impact probability, and that's going to be somewhere around the year 3000, just a little bit earlier. So as you can tell, we're trying to track these things. But look up the Sentry database. I think that the Sentry database will be really interesting to look at, and when you realize, wow, that's pretty cool, But anyway, I think that the Sentry is something that we're tracking. It's we have these deep space networks that we're using to try and identify these asteroids. However, you might say, well, then why didn't we ever find Oumuamua? Remember Oumuamua? Yeah, Oumuamua was initially thought to be about 700 feet long, 70 feet wide. Well, now the new estimates for Oumuamua put it around 1,500 feet, possibly even 2,500 feet long, and a tenth of that wide. So 1,500 by 150, 2,500 by 250. I mean, it's really quite an amazing size difference. But I did a little something, and we're going to talk about that in a little bit. I wrote a program that calculates asteroid impact damage, and I actually calculated what would happen to the Earth if Oumuamua struck us. And now there's a lot of factors that go into that, but we'll talk about that at the beginning of the next segment. But I just want to mention, that initially Oumuamua was thought to be a comet. In fact, it was classified as a comet at first. But when it got closer to the sun, it didn't do the things that comets do. And what do comets do when they get closer to the sun? Amanda, what do they do? That's putting you on the spot.
What do comets do?
Yeah, as they get closer to the sun, what do we see?
Tails.
That's right.
Okay. I thought we saw tails the whole time. I didn't know it had to be close to the sun to see it.
Yeah. If you think of it this way, all the Kuiper Belt objects that are way out past Pluto, those could be comets, likely, or possible comets, if they got closer to the sun. All it means is they're covered with many different types of ices, which we'll talk about in the next segment. All right, but these ices that they give off could be could be volatile, meaning they could come off with heating, and then the comet or this object could outgas, and thus something that looks like Ultima Thule did to the New Horizons spacecraft could be a comet. If you look at Ultima Thule, it didn't look that much different from Churyumov-Gerasimenko, Comet 67P, did it? But more on that when we get back. This is Mark D'Antonio with Daryl and Amanda and Daryl. And we'll be right back right after these words.
AncientLifeOil.com. For your CBD needs, just remember, AncientLifeOil.com. What does it do for the body, you ask? I can't say to the people in the suits that run the industry. Big Pharma's all over CBD because of its well, you know what I mean. Research the benefits of CBD on Google and come back to AncientLifeOil.com and purchase your CBD today. Non-GMO and all organic. You don't want to be using a petroleum product. You want to be using the cleanest CBD product on the market. AncientLifeOil.com. We even have CBD for your pet. Help your pet's discomfort. Help your discomfort. Log on to AncientLifeOil.com. That's AncientLifeOil.com. Newly reduced prices to pass off the savings to the most important person. You. AncientLifeOil.com. And one more thing. We have topicals too. So if you have joint pain and some different issues that are going on in your body, you might want to use a topical. Think about it. AncientLifeOil.com.
Okay, nurse, let's get this man to the ER stat.
Right away, doctor.
We see this every day. Heart attack or angina pain due to blocked and clogged arteries. Chelation can remove obstructions or blockages from arteries and help avoid painful and expensive surgery. Now there's Angioprim. It's a liquid oral chelation product that you take with juice. You start to feel the results fast. Angioprim increases blood flow all over the body, and that means more energy and strength to take on the day with less aches and pains. 60 years of research has gone into chelation, and Angioprim is the result. A safe and easy way to unblock your veins and arteries from buildup that slow circulation.
Paging Dr. Jones. Please report to the emergency room right away.
Log on now for a special radio offer from Angioprim. That's angioprim.com/radio. ANGIOPRIM. Angioprim.com/radio or call 877-882-7221. That's 877-882-7221.
Get ready, Knoxville, Tennessee. The Alien Expo is coming August 17th and 18th at the Knoxville Convention Center. Prominent top-level UFO researchers and experiencers from around the world present Real X-Files, encounters with UFOs, true alien abduction accounts, contact with extraterrestrial beings. See America's most high-profile contactee, Travis Walton. Hear about bases on the moon from former NASA aerospace engineer Ken Johnson, MUFON abduction expert and niece to Betty and Barney Hill, Kathleen Martin, UFO truth embargo and disclosure advocate Stephen Bassett. Come and enjoy a full weekend of presentations, music, vendors, meet and greets, book signings and autographs, cosplay, alien costume contests, and more. Day passes, weekend passes, and VIP passes available now. The first annual Alien Expo, powered by Mysterious Radio. Make contact at alienexpo.com.
Mainstream media's most wanted. KGRAradio.com.
Hey, welcome back to Sky Tour Radio. This is Mark D'Antonio here with Amanda and Daryl. You know, we were talking about Oumuamua just before the break, and we're going to dive into that and some of the things that could happen or might happen if Oumuamua were to hit the Earth. But before that, I would like to address some of the questions that came in during that last segment because they're actually really good. One of them, X-Lady asked, how much did they get from those meteorites? Now, she meant the meteorites that the ones that struck the lady, the one that was found, through the trunk of that car. I don't know either how much they were worth or what they did with them. I really don't even know where they are. They might very well be in a museum somewhere.
That's what I was going to ask. Did they sell them? Like, if that happened to you, would you sell yours? Would you want to keep it? Or would you even have a say in the matter? Does someone automatically come and take it anyway?
Oh, no.
I'd tour the country, man. I'd show it, say, this thing struck me while I was watching TV.
It's sort of like Mike the Headless Chicken. No, Amanda, if a meteorite falls on your property, you are the owner.
That's right.
If a meteorite falls on government property, the government owns the meteor. They cannot come and take it away from you if it's yours, if it fell on your property, for instance.
That's right. That's
would you guys, if it fell on your properties, would you guys sell it or donate it to a museum or experiments, or would you keep it?
It depends on the meteor. A regular nickel iron meteorite, they're worth some money. They're not worth tons of money.
They're very common.
Yeah, and I've known of people who have used meteorites for door stops and such. Some meteors are very rare, and they are literally priceless. They're worth more than their weight in gold, and some are literally priceless.
That's right, yeah.
And I hope to touch on this when Ronald's question comes up.
Yeah, I was going to say, worth their weight in gold. Ronald's ears perked up. He does say hello, by the way. We'll get to his question shortly.
We will.
But asking about keeping them or donating them kind of leads to our next question from Overlord. They said that they heard a lot of talk about rocks in space soaking up radiation. Can meteorites not be radioactive?
I might defer to Mark on that. I wouldn't. Well, what the radiation they're picking up out in space, it's not ionizing radiation, I would say. So therefore, they're not radioactive, so to speak, or not in a dangerous sense anyway.
Yeah, see, the only radiation they would be picking up is the radiation that the sun already gives off, for instance. And that radiation is radiation that Earth already deals with and that we can deal with. And it's absorbing some of it, but it's not doing anything but radiating heat generally.
Yeah.
So I don't expect that meteorites would be dangerous to your health. In fact, there's a lot of health benefits to having a meteorite. If you have one in your pocket when you're being mugged, you can use it, man. You could get rid of that guy all the time. Just bang him right in the head.
Keep it in a sock. I can tell a funny story about radioactive meteorites, actually. I have, like Mark, I have a nickel iron meteorite. It's about the size of my fist, maybe just a hair smaller. It's a Canyon Diablo from Arizona, the meteor that created Meteor Crater down there, Barringer Crater. And I was so proud of that thing when I first got it. I left it in a box in my car, and it rode around with me a lot. And you know how cars get hot in the summertime. Well, I took it into a diner I used to frequent one evening for dinner. And I called the waitresses over, and I took out my meteorite. I was so proud of it. They were afraid. Huh?
I sense a practical joke here.
Well, not really, but it kind of turned out that way, maybe. The meteor was extremely warm to the touch because it had been riding in a car all day in the summertime. And I set this thing down on the counter and said, wow, look, isn't this cool? And one of them picked it up, and she gasped and put it down immediately. And that made the other ones afraid to touch it. They thought it was radioactive.
Because it was hot.
And, yeah, it was hot to the touch. And that's all it was. But, hey, radioactive, maybe it was warm from the sun.
You say, I wonder why no bugs bother me and I don't get mosquitoes near me at night. Holy cow.
Yeah, makes my hair shiny, too.
Wow.
Amanda, I might have had the same reaction, actually.
Well, yeah, I mean, if you don't know.
I picked up a meteor or a piece of a meteorite or something, and it was still warm, I don't know.
Yeah. You might not be surprised, though, how many people have similar reactions, even if it's not warm to the touch. When I did public programs back in the 90s, I often brought several meteorite samples with me, the Big Canyon Diablo and other little ones, and they would pass them out in the audience as I gave my talk, and a lot of people were afraid of them. They refused to touch them. This is sort of an Andromeda strain kind of thing. If you remember the old movie or the book by, what's his name?
Crichton.
Michael Crichton, thank you. A lot of people are just plain afraid to touch meteorites because they think, it's going to give them some alien disease or something.
Yeah. Well, it will, and it did. So anyway.
Yeah, there you go.
Well, I don't know. I seem to remember that kind of being the vibe. When I was younger, if I ever saw kind of space movies or space television shows or something, like
sure,
the piece of meteorite kind of pulsating or giving it a sound or giving off a light when it's dark or you know. So I can understand why people would be a little leery.
Yeah. This is world of the worlds kind of stuff, yeah.
Yeah, exactly. You don't know.
Yeah.
So now I want to continue with our questions here, guys. We have one from Blue Orb. He says, when a meteor enters the atmosphere, does the compressed atmosphere act like a pressure vessel helping create the explosion? I think I get the gist of the question. And yes, at 25,000 feet, you're above half of all the atmosphere on the Earth. So essentially, as the meteor starts to enter the Earth's atmosphere, remember it's moving at a high rate of speed, and to humans, 25,000 feet and above is very thin atmosphere. But to a meteor coming in at that speed, the atmosphere is thick, up at around 70 miles for a meteor coming in at that speed. So it's going to really, really superheat, and it will reach effectively a wall. And it depends on its mass, depends on its composition. And that wall will, in fact, break it apart at some point if it can be broken apart. Sometimes they're very cohesive and they won't break and they reach it all the way to the ground, in which case they, blow a big hole in the ground. Sometimes they break apart in the high atmosphere, come down and make several craters. So it is like hitting a wall, and it varies by meteor type and meteor speed, and most importantly, by the angle of attack, the angle at which the meteor is entering the Earth's atmosphere, 90 being straight down and, 0 being, straight across the atmosphere without actually entering the atmosphere. And at shallow angles, then the atmosphere acts like water. And what happens when you skip a stone? All right, the meteor will skip right off the atmosphere in the same way that a stone skips across water. All right, and that's why when spacecraft come back from space, they have to have a certain angle of attack to enter the atmosphere. Otherwise, they too can do that skipping stone routine and end up, heading off with Major Tom and end up out there floating on their tin can. Know what I mean? So that's impressive, that we've figured all that stuff out, I think. And now I think that, Daryl, you said you wanted to answer Ronald's question. His question is, some say we have meteors with the composition of Mars. How is this? Go ahead, Daryl.
Well, it's easy.
I like that question. That sounds pretty cool.
That's great.
Something hit Mars hard enough to knock chunks off of Mars. And those chunks flew around out in space until they intersected Earth's orbit. And some of them survived to make groundfall here. There are 3 kinds of Martian meteorites. They're acronymized, whatever, SNCs, if I remember correctly. There are Shergotites, Knocklights, and Chassignites. Starts with the letter C.
There will be a test.
Yes. There are 3 different kind of rocks, I guess you would say, Martian rocks, but probably analogous to something here on Earth. I'm not going to go into details because I don't remember. But yeah, we occasionally, very occasionally, Martian pieces of Mars are found here on Earth. And that's how they got here. Something hit Mars. Something got knocked up into space and eventually landed on Earth. These are among, if not the most expensive meteorites also. They are literally priceless. Comparing them to the cost of, their weight in gold, it's not even close. They're literally priceless. And that's how it happens.
And think about this. There's over 60,000 of these here on the planet. Okay. So, that have been identified so far, so it's actually, let's see, 61,000 meteorites that have hit the Earth, and only 200 and so have been identified as Martian. So that makes them rare right off the bat.
Yep.
Yeah. Yeah.
And there are also some meteorites from the moon they've identified, and they're in the same basket as the Martian meteorites. They're so rare, they're just extremely expensive. You wouldn't believe.
I'm glad you said that. Kathy just came in with another question. She wants to know, have any meteors from Venus or Mercury ever been found on Earth?
Not that I'm aware of.
Not that I've ever heard of either. Certainly some from the moon. And by the way, when the Earth is struck by a meteor, sometimes you can get remnants of that meteor strike in part of what we call the ejecta blanket. That is, the ejecta is the debris that's thrown out by an impact. And this stuff goes really high up into the atmosphere as molten blobs, and then it cools and then falls back to Earth. And you find them, and those are tektites.
Yep. I have a bunch of tektites.
Yeah, a lot of people have these tektites. You can get them from Emmett Scientific. You can go look for them, and they're really cool. They're shiny like glass in some ways, and the true tektites have an interesting shape to them as well. So it's pretty cool.
Yeah. Some of them are streamlined from their passage while molten through the Earth's atmosphere.
That's right. They have that teardrop shape. Yep.
Yep.
Yeah.
And Daryl, going back to what you were saying, if meteor lands on your property, it's yours. Government property, it's theirs. What if you find one in a public park?
Okay, this comes up surprisingly often. Well, one of the big things when a meteorite is discovered, and if you say, hey, I found a meteorite, and the powers that be find out, well, what they want is documentation. What's the word I'm looking for in antiques? It's the same thing. That they will want, if you come up and say, hey, look, I have a meteorite, and the people are going to go, well, where did you find it?
Well, here's my authentication for you.
Right. They will want to know exactly where you found it. This is for scientific reasons, because if you found one, there are likely more in the areas, and they want to know where to go search for more of the same, meteorite.
Right.
But it will come out that they want to know precisely where you found it. And if it's not on your property, well, you're SOL. Okay.
Unless you just do what everyone listening to this show would do and say, hey, I found it in my front yard.
Yep. The word is provenance, by the way. I mean, they want provenance for every meteorite known. Scientific reasons, so they can go out and look for more. If you tell the truth about where you find yours, they're called strewn fields, where the meteorites tend to fall in an elliptical pattern along the path of the meteor in the sky. And they want to go out and search that strewn field, because there's likely to be more. The Chelyabinsk meteorites are a good example of that.
Yeah, like when I mentioned, where you start to see the meteor burning up in the atmosphere, there's particles and pieces of it coming off at that point. So in the direction it's traveling from where it starts to get smoke in the atmosphere to where it finally explodes, all along that path on the ground is going to be some elements of that meteorite. They could be particles, they could be pebbles, they could be the size of small marbles, they could be even bigger. And that's the thing that I'm sure the Chelyabinsk meteor hasn't even been fully collected. Because there's a lot of lakes and stuff that it fell in on ice and so forth, because it fell in the winter, I believe. And made a perfectly round hole in the lake where it went in finally, I think. And that was the biggest chunk. And they actually retrieved that from the floor of that lake. I haven't seen it, though.
We had one come in here over town early in the morning years ago. It was thought its terminal detonation happened very low to the ground because the flash and the boom were nearly simultaneous. It blew up over the east side of town, just a couple of 3 miles south of me, supposedly. I slept right through it, but it knocked my neighbor out of bed. It was that big a boom.
Wow.
And they never found it, okay? It was moving from west to east at a fairly shallow angle. It exploded right over the east side of town here, and they think it hit the ground out east of town somewhere, out on the prairies. The last I heard, they never did find it, and I'm sure Dollars to Donuts, there have been people out there looking for it.
Yeah,
last I knew, though, they didn't find it.
Well, people typically underestimate where those things land. And give me an example. I got a call at 2 a.m. one time from state police asking about this meteor that went into a lake right nearby here. They said there was this green fireball and went right down into the water. Okay. And I instructed them what to look for. I said, okay, we got to look for run up of the water at the boat landing, see if something splashed in the water. Something moving that fast with that kind of energy is going to make a big splash, and you're going to get like a mini tsunami, basically. Not, like maybe 2 feet, 1 foot high, whatever. But you'll see freshwater run up on the boat landing, and they didn't find any. And I said, okay, in the morning, go look for mud in the water. See if you can, you get an aerial view of the lake and see if you can see any kind of muddy patches that are different from elsewhere in the lake, because that would be where it hit the bottom. And nothing was found. So then I thought, okay, most likely what this was one of these earth grazers. And from the perspective, because we live on a sphere, you will see that things that go parallel to the ground and then leave, travel, through the atmosphere and continue on out. These things will actually appear to be going down, just like a jet contrail. A jet that goes over the horizon, the contrail will look like it's going down near the horizon. Well, a meteor is another one of those examples. A meteor that's flaming in our atmosphere and is going to be grazing across the atmosphere is going to do just that. It's going to look like it's going down. So this is what led to the popular and unfortunately erroneous assumption that it landed in the water. So, nothing was found. There was no explosion of this one, which when they explode, we have a different term for them. It's called a bolide. But that's neither here nor there. Don't worry about that. Just don't get hit by them.
I mean, it's fireball.
Yeah. No. I want to. And speaking of meteorites, I want to talk about something else. A recent news story that might be interesting.
Is it regarding Charles's question?
No, not yet. It's actually in regards to what I'm going to let Daryl tell us about. It has to do with the Taurid meteor swarm. Now, you wonder what the heck is that? Well, Daryl's going to tell you. Go ahead, Daryl. Let's hear about the Taurid swarm.
Very good. Amanda, feel free to post that link if you like. I'm just going off this Sky and Telescope article. Astronomers, astrophysicists, they are presently on the watch for members of what's called the Taurid swarm or the Taurid resonance swarm. These are asteroids. These are actually chunks of a comet, it's believed nowadays, that follows the path of Comet Encke around the sun and intersects the Earth. The Tunguska event meteorite, the one that hit Russia in 1908, is thought to have come from the Taurid swarm. This is the same bunch of meteors, comet chunks, that produced the Taurid meteors in October. And they are predicting now that this Taurid resonance swarm, which is in a resonant relationship with the planet Jupiter. If I remember right, it's 7 orbits of the Taurids for every 2 orbits of Jupiter tends to make this one batch of Taurids clumped together in a certain part of the orbit.
Yes.
And They think this is where Tunguska came from, and they think we're encountering it now, or they're watching for it now. Since June and this month in July, they're watching the skies for members of the Taurid swarm. I haven't heard of any results from it yet, but hopefully we will hear something.
Well, we should be able to look for something too, shouldn't we?
Yeah, but you may struggle if you're like an amateur astronomer. The sensitivity of the camera required is such that they're more likely to be seen with a professional telescope, just because they have more aperture and can see much dimmer objects.
Yeah.
But sure, you can go out and look. Do a Google search, read that Sky and Tel article if you can see the chat room, or just search Sky and Telescope stalking the Taurid swarm. And that will get you started, and there's tons more out there from there if you have an interest.
Okay. And that's thank you for that, Daryl. That's really interesting. So when Daryl said this resonant swarm, what does that mean? It means that when we have a comet, say, that's going around the sun, comets are generally in these elliptical orbits. Well, Jupiter's also kind of like a shepherd in our solar system. It will take batches of particles and alter their trajectories. And because the solar system is a stabilized environment that's had billions of years to settle down, certain things happen, and they end up happening kind of the same way every time. In the same way that Jupiter's moon Io will go around Jupiter precisely, a certain number of times compared to the next moon out and the next moon after that. That's called a resonance with the moons. Well, with these meteors or particles, whether they're smaller or larger, this material ends up getting caught by Jupiter's gravitational field as well. And over the billions of years that this swarm has been out there, Jupiter tends to bunch the particles up in a certain spot in this cometary orbit. And so this is the kind of thing that we see. And so once in a while, we have this big swarm of particles that manages to get around in the orbit. It's nowhere near the comet. The comet's nowhere near it, actually. But these are particles that came possibly from the comet. And these particles end up in their own little orbit. All right. And so that's the resonant swarm. That's what that resonant thing means. It means that another body is helping to shepherd these particles. And so that other body happens to be Jupiter in this case.
Yeah. The term is orbital resonance. Sorry.
Yeah. The orbital resonance of the moons, for instance, and orbital resonance of these particles that are part of this Taurid resonant swarm. So I think it's kind of cool. It's really neat to see this, and I'm really excited about that. And you know what? I don't know. Maybe we could find something. Maybe we could see these. It depends. You have to have a dark sky sight.
Oh, yeah.
Speaking of that, I got to pass on. I talked to the people that own the land that I would like to set up the Sky Tour live stream observatory on in Arizona. And the owners have signed off on being able to do it. They want me to do it.
Wow, cool.
So I now have a place, the definitive place, to put the Sky Tour live stream observatory underneath a beautiful dark Arizona sky.
Super.
So that process will begin as soon as I am able. I have to go to Norway next month too. I've got to speak in Oslo and Bergen and Lunda and I think one other place. So excuse me, none of this is going to happen till after I get back for sure. But I think that this is all about science, and I like bringing science to people just like you do, Daryl, just like Amanda. She likes to learn science. She actually you never realized you like science until we started doing, the Sky Tour live stream here in the observatory. And then
I always loved science. It's just my poor math skills held me back.
Well, see, that's the thing, okay? I think science is for everybody, and I think that no matter what your math level, you should be able to have a full understanding or at least a foundation to understand what's going on out there that doesn't require the math. And I kind of look at it as that's what I'm doing. I'm trying to provide the foundation that doesn't require mathematics.
And I think others as well as myself, are really appreciative of that. I mean, there's a lot of smart people listening, a lot of smart people in chat that can really hang with you, but, you know, for someone with a very, very basic knowledge like myself, you really make it easy, and Daryl really makes it digestible, that you can...
Easy and digestible, isn't that what it's supposed to be?
Well, I mean, you would hope so.
I'm sorry.
That's okay, Daryl. That's okay. No, I'm not making. I'm certainly not making fun. I'm actually saying, you know, easy and digestible is a very important thing.
Everything's better with Amanda.
Well, look, we know that science is for everybody. It's not just for the people that have degrees. It's not just for the people that are math whizzes. Science is for everybody. We're all going to understand science by the time we're done. And that's the whole idea. That's what Sky Tour Radio is about. That's what Sky Tour Livestream is about. That's what Daryl's about. That's what Amanda's now about. It's impressive to look at. In fact, I'm going to just embarrass you a little more, Amanda. It's impressive to look at Amanda's knowledge level and compare it now to what it was when we first started. You know,
hopefully I ask more intelligent questions, at least.
You do. Yeah. You've come so far since your first step in all this.
And you know what? I have to say this before we go to the break. The other thing is, when Amanda, in the beginning, she would just sit there quiet as a mouse and wouldn't say anything unless I said something. Now, she'll sometimes finish my sentences. You know, and that's the confidence speaking. That's the confidence of the knowledge. See, and I love that. And that's what I wish for all of you listening here. And again,
and that's why I love when chat brings in questions of their own, because I mean, it gets me thinking. It with Kathy asking how much they sold them for, I was thinking, would you even sell them? Would I sell them? Yeah. Would you have to sell them? Do you even have a choice? And then it just gets me spiraling at it. And I have people that have the answers or know where to find the answers. That's you know, so it's quite a privilege to be able to do this.
It is, and we're going to have more answers when we come back, because we do have to take another break. But when we come back, we have a few more questions from you guys that they've asked so far.
Keep them coming.
Keep them coming, and I'll see you in just a few minutes with Amanda and Daryl. See you later.
Ready, Knoxville, Tennessee. The Alien Expo is coming August 17th and 18th at the Knoxville Convention Center. Prominent top-level UFO researchers and experiencers from around the world present Real X-Files, encounters with UFOs, true alien abduction accounts, contact with extraterrestrial beings. See America's most high-profile contactee, Travis Walton. Hear about bases on the moon from former NASA aerospace engineer Ken Johnson, MUFON abduction expert and niece to Betty and Barney Hill, Kathleen Martin, UFO truth embargo and disclosure advocate Stephen Bassett. Come and enjoy a full weekend of presentations, music, vendors, meet and greets, book signings and autographs, cosplay, alien costume contests, and more. Day passes, weekend passes, and VIP passes available now. The first annual Alien Expo, powered by Mysterious Radio. Make contact at alienexpo.com.
Hey, is that a new music app?
Yeah, check it out. Surfer Music Discovery. It links to thousands of online stations, but the twist is you see the song names and artists that are now playing live.
That's different. No guessing. Looks like a waterfall of music.
So many formats. Rock, oldies, country, R&B, jazz, and a whole lot more.
How's that spelled?
Surfer. S-U-R-F-R.
Is it expensive?
It's free. No need to sign up or sign in.
Get the Surfer Music app free from Google Play or the App Store.
AncientLifeOil.com. For your CBD needs, just remember, AncientLifeOil.com. What does it do for the body, you ask? I can't say due to the people in the suits that run the industry. Big Pharma's all over CBD because of its well, you know what I mean. Research the benefits of CBD on Google and come back to AncientLifeOil.com and purchase your CBD today. Non-GMO and all organic. You don't want to be using a petroleum product. You want to be using the cleanest CBD product on the market. AncientLifeOil.com. We even have CBD for your pet. Help your pet's discomfort. Help your discomfort. Log on to ancientlifeoil.com. That's ancientlifeoil.com. Newly reduced prices to pass off the savings to the most important person, you. ancientlifeoil.com. And one more thing, we have topicals too. So if you have joint pain and some different issues that are going on in your body, you might want to use a topical. Think about it. ancientlifeoil.com.
Are you intrigued by Paranormal Talk Radio? You'll love the new Paranormal Radio app from TalkStream Live. You'll find a great selection of talk shows covering UFOs, ghosts, strange phenomena, and much more. Download the Paranormal Radio app now and start listening to the very best in paranormal talk entertainment, including the network you're listening to right now, the Paranormal Radio app. Free in Google Play and the iOS App Store.
Your official contact for the best alternative talk on the planet. KGRARadio.com.
Hey, welcome back to Sky Tour Radio. This is Mark D'Antonio, and I have Amanda Curran, my wonderful co-host, and Daryl Mason is with us as usual, which I kind of like. I like the sound of that, Daryl, as usual. That's pretty good.
Sure.
You know, you're always saying everything's better with Amanda, and that's true. But you know what? It's also pretty darn good with you.
Oh,
that's wonderful, Daryl.
Stop.
If it does stop, you'll say, "Wait, aren't I still good?" You're
yeah. Don't give me a big head, please.
No, you're not like that. That's why I can compliment you, because I know it won't go to your head. It's very rare. It's very rare to find people like that, and I like that. It's an ego-free zone here.
Can I say something here?
You may.
Ronald, put down your pickaxe. Stop being a gold prospector. Get yourself a good metal detector and go out and start hunting for meteorites.
He's in a prime location.
He is.
He lives in a postage stamp.
Well, get out there on those prairies and start sweeping that thing, and you might be amazed what you find.
Yeah, and of course, then we'll be hitting you up for a loan when you find that very rare meteorite that's worth $200,000.
Yeah, he'll be sitting with his feet up like the Monopoly millionaire smoking a cigar. He'll probably have meteorites rings on both hands.
That's right, and clock faces. They're polished meteorite faces.
There you go.
Yeah. You know what? I want to say we had a question from Blue Orb. That he asked about there being an Earth meteorite found in a lunar sample. Is that? I don't remember that being the case.
I think he said about 50 years ago. So
Yeah,
I'm
well,
wondering if that's because that's
follows.
coming up. The anniversary is coming up any time now. I forget the exact day. Was it
6 days from now.
6 days?
Yeah, 6 days from now. Not that I know anything about it.
You might know a thing or two about it.
Yeah, but he said Earth meteorite found in a lunar sample. Well, it's kind of interesting because if you think about it, the way the moon was born, we suspect that a Mars-sized body, hit the Earth. And, of course, fractionated a lot of the Earth out, as well as the impactor itself. And what came out was a molten mass of rock. The Earth was made molten again, for sure. And then when everything cooled, like I said a few times in the past, Earth probably had a temporary ring, which then coalesced into a proto-moon, which then solidified. And as it got harder, the core, of course, was very hot. And it differentiated, so any materials in it that were heavier would sink toward the center of the moon, over the time it took for it to cool. And then the surface of that body was just peppered by the debris. And we were talking about, we had several billion years ago, we had a bombardment era where a lot of debris from the solar system struck the moon and the Earth. And people say, well, the moon has protected us. And I say, actually, I don't think it really has. I think the moon has actually helped us become a target because it has its own gravity that's pulling stuff our way. And once the stuff gets near us or near the Earth-moon system, we're the bigger body. So it might find its way to us before it actually strikes the moon. The moon is just a sentinel out there at some distance, pulls stuff toward us, and then the Earth soaks it up. So I'm not sure that the moon did us any favors that way. So all the impacts on our planet could be the result of the moon helping it to happen. So who knows? On an exoplanet, what might happen if it didn't have a moon? Would it have more or less impact scars? That's a question we cannot answer unless we get a real good taste and understanding of what the moon's role in the early solar system was. But think about that. Isn't that cool? That's a neat thought.
The biggest objects that have hit the moon hit on the side facing us, didn't they? Which created the lunar seas, the Maria, Maris.
Well, actually, that's not. See, the moon was tidally locked to the Earth before the bombardment era. And we know this for a very important reason. If you look at the moon, you look at the far side, you'll see that there's lots and lots and lots of craters and very little Maria, those dark gray seas, so to speak. There's Mare Moscoviense, okay, and then there's Tsiolkovsky. They have a little bit of Maria in them, and the Aitken Basin, the lowest spot on the moon, actually is on that far side, down in the lower part of the southern hemisphere. And there's not even Maria down there. There's more cratered highlands again. So what happened? When the Earth was still molten and the moon was out there, the moon was closer and it was spiraling away over time. The moon was subject to the Earth's radiative energy in the infrared because the Earth was molten and cooling. It was very, very hot, and a lot of that infrared energy was going toward that moon. So any impacts that struck the moon would bring up a gigantic plume of dust and debris, which would be molten. And then the infrared radiation, that the strength of that infrared radiation pelting this stuff would actually make it drift to the far side. And so what happened was, over time, this is a theory, by the way, that I read about in one of the journals. Over time, the far side grew thicker than the near side. They weren't always that way. And thus, the near side ended up with a much thinner skin, so to speak. And the moon is not spherical and equally dense throughout. It's actually oblong. Its center of mass is actually shifted toward the back, as seen from here. So that means that the moon is sort of like unbalanced in a sense. So that radiative energy managed to push a lot of that debris over the limb of the moon and where it fell down into the backside. Zoom ahead a couple million, 100 million years, and you're getting a denser far side. Yeah. And so things that strike on the near side could, again, bruise the moon enough to make it have this big flood basalt, in the same way that we talk about the flood basalts here on the Earth with the Siberian traps during the Permian period, which caused the whole process we talked about last week, in the same way. So the moon, the early moon, was a very interesting place, I'm sure, and I know that that process is only a theory. It's a hypothesis, but it looks like it's the real only explanation for why the moon is thicker on the backside than on the front. Something about the way the moon formed and became tidally locked. Of course, tidal locking had to happen first, because if it was rotating, it wouldn't be thicker on one side and the other. It would be even. So it became tidally locked, and then this stuff occurred. And the only explanation seems to be that the radiative energy from the early Earth, the infrared heat, was driving material past the edges of the lunar limb onto the far side when there were impacts. And we're talking about very fine material, in the whole process overall.
Yeah, I see what you're saying. Fascinating. I had always just visualized, the Earth being the bigger target, the deeper gravity well, that maybe it drew, asteroids or whatever, big meteors down, and if they missed us, then the facing hemisphere of the moon was, a likely target if it did miss Earth. But I absolutely see what you're saying. That's interesting.
Yeah, I mean, that was just it was a hypothesis. I actually talked about that in SkyTour live stream last year.
I remember that.
Yeah. You were there, I think, for that. Yep.
And I forgot.
That's okay.
So
it's totally okay. Amanda was there.
I'm usually there.
Yeah.
Usually lurking in the backgrounds.
She was there.
Mhm.
Yeah. Yeah, and you know what happens sometimes with SkyTour live stream anyway, I get on a roll And it's like sometimes I forget I got to take a breath. You know, I mean, it's so cool. And there was some nights we actually had. I remember being taken back by the sight of I think it was the Veil Nebula in Cygnus. For the first time, I had imaged it, and it happened to be almost directly overhead. And when I imaged it, I literally couldn't breathe when I saw the result. It was so stunning. I had never seen it before in that telescope.
Well, that's why people keep coming back to you, because you are still passionate about this. I mean, you've known since you were 9 that you were going to do this, and you still get excited, and you still, you know, it's contagious. And I really believe that's why people come back. I mean, maybe for selfish reasons, want to see stuff that they want to see, put in requests and stuff, but whatever you pick is gold, and your reactions are just infectious.
Oh, well, I guess that's because I never stopped being willing to learn.
Mm-hmm.
You know, I never felt like I was the end-all, be-all expert. I never became comfortable with that position, even though some folks have said, well, you know, you're the most knowledgeable guy I've ever... No, you know what? I can give you 10 more people that are more knowledgeable than me. Everyone's different. They all have different capabilities. And so I'm okay with the compliments, but I'm not going to sit there and take it seriously and have it go to my head. I'll smile and say, oh, thank you. You know, but then, you know, I realize that's not all there is. There's so many people out there that are just so incredibly intelligent, you know. Now, speaking of intelligence, I wanted to mention that in the chat, we actually had a question. Let's see. Was it Libertas? Left us a question here.
Did I miss it? Let's see.
He said using color to search for alien Earths.
Oh, he sent you an article. Yeah, I
Right.
didn't get a chance to read it as of yet, but he wanted you to take a peek at it. Did you have a chance to look at it, or?
Yeah, no, I'm familiar with that, and that harkens back to something that Carl Sagan, my favorite astronomer, who used to call the Earth a pale blue dot in the universe. Okay, he actually had the Galileo probe turned back toward the Earth while the Galileo probe was on its way to Jupiter, because he wanted to have a database created and started anyway that would show us the different types of how different types of ground, for instance, on a planet would look to the Galileo. So, does water look the same as desert? The answer was absolutely not. Do dense, lush rainforests look the same as ice caps? Absolutely not. Okay, there's what's called the reflectance index, and then there's this color. Well, what's interesting is the amount of light you get in certain wavelengths can help you determine from thousands of light years away whether you're actually looking at a planet that has plants on it. In other words, whether you're seeing photosynthetic life. Now, the James Webb Space Telescope is slated to go up next year. We say that every year. You know, with next year being the next year, you know, whatever it is. And I'm saying that in all jest because of the fact that I want them to get it right. So when it goes up, it has to work perfectly. And James Webb cannot look for oxygen in an atmosphere directly. Oxygen, you see, is in the visible wavelengths. It's actually something you would see in the visible wavelength. I can see it when we do spectra in SkyTrail Livestream. We see spectra of the sky. We actually see the dark lines, the absorption lines that are created by oxygen and water vapor in our atmosphere. Those are called telluric lines, and we can see those in the visible end of the red spectrum. Well, the James Webb Telescope is looking far past that into the infrared. Its instruments are infrared, so looking for the heat, basically. Well, so we don't see oxygen, and we won't. So you might say, well, then how are we going to find if there's other oxygen on a planet's atmosphere? Well, the answer comes from looking at other things that will infer oxygen. Those other things are carbon dioxide and methane. And depending on the quantities in the atmosphere, which, by the way, those lines appear out in the infrared, and the James Webb Telescope will be able to see those. And because they occur way out in the infrared, by seeing the quantities and being able to measure the quantities, we will know, based on our own experience, that certain quantities mean, hey, there's oxygen present here. and we'll be able to determine that. Now, in addition, we could actually look at the planet's reflectance index, the light coming back to us effectively, and see what we're looking at and decide, hey, is this a glaciated planet, covered in ice? Or is this a forest planet? Is this just a rock ball with no atmosphere? Is this just a water planet? We'll be able to know, because when Carl Sagan had Galileo probe looking at the Earth, they figured out what a water planet looks like, what a desert part looks like, what ice caps, what lush forests look like. And they started building a database. So they'll be able to use some of this reflected light and very specific frequencies of light coming from the planets that we're looking at way thousands of light years away, as I said, to determine if we're actually looking at planets that can hold a habitable life form, hold habitability for us. Let's put it that way. So it's pretty cool. So that's what I think it was Lib, right? Libertas. I think it was. But he actually put that in an article, and the article is there's a video associated with it. But if you look it up, it's on the NASA Exoplanet Exploration site, and it's called "Using Color to Search for Alien Earths." And Lib, I want to thank you for that. That was very kind, because that was actually very timely, considering that we're talking about what kills planets. And now we're looking, what you're offering is how we can also find planets that have life. Very cool. Now, I want to go back. Now, unless, Daryl, you have a question, or Amanda, you have a question, or if we have questions coming in that I can't look at the moment because I can't see that screen.
Not at the moment. I am keeping my eye on things, but like I said, keep them coming, guys. That's what we're here for.
Awesome.
Mm-hmm.
All right.
I'm good. Carry on.
Awesome. So we started. We said. Remember, we were talking about Oumuamua. And Oumuamua was, and they say, well, it could be up to 2,500 feet long and 250 feet wide. Maybe, I figured, okay, it's going to be somewhere between the 700 and 2,500. I just picked a number. I said 1,500 by 150 feet. It was 10 times longer than it was wide. So what I did was I figured out what Oumuamua would have done to us had it struck our planet. Now, you have to understand that Oumuamua was moving pretty darn fast, and we'll get to that in a minute. But what I did was I took Oumuamua, that long, basically cylinder, and I converted it into a sphere of the same material, just to be able to put it into my asteroid impact program. It's not going to cause the same effects. The cylinder might have caused more or less damage than a sphere. The cylinder would have broken up easier than the sphere, unless it came in like a needle and weather vaned, which is possible. So we don't really know. But the fact of the matter is, the bottom line is, what was Oumuamua? Okay, well, some, as I said to you before, they thought it was a comet, and that's how it was classified at first. But then when it got near the sun, they noticed that the surface didn't show any of that outgassing like you see on a cometary surface. Now, what is outgassing? Well, comets are made of mostly ice particles, or mostly ices. And when we think of ice, we think of water ice, okay? But it's not just water ice. It's methane ice. It's carbon dioxide ice. It's cyanogens. It's ammonia ice, and various other, hydrocarbons, And, cyanide is actually, these cyanogens on a comet are what make it look green when you take a photograph of it. Or sometimes even see it in the eyepiece. It's the cyanogens which give it that green look. And I think it was a Flammarion, wasn't it, that said that when if there was a comet that was going to pass through the Earth's atmosphere, we're going to pass through its tail. And he said that because it had cyanogens in it, it was a very possible, it could be, he said, he wasn't trying to say it was going to happen, but he had to open his mouth and say, well, it's very possible that the cyanide could cause the extinguishing of a lot of life on the Earth. And of course, that started panics, and people started buying anti-comet masks and
comet
anti-comet
pills, all sorts of things. Yeah, Flammarion was the 19th and early 20th century's Carl Sagan. Okay, he was a great popularizer of science and astronomy, and he made that prediction, and it scared a lot of people around the world.
It did.
Sir Arthur Conan Doyle, the guy who wrote the Sherlock Holmes novels, he wrote a story about this. Like a big belt of poisonous gas that the Earth flew through, and it flew through the comet's tail, and what it might have done to the planet. This is an interesting story. I can't think of its name offhand.
Yeah, I mean, and we actually, I believe it was you that sent me the link to that story. Yes.
I think it was. Yeah.
Yeah, and we talked about it at one time. I remember that. Really, really interesting. Yeah. And I know that. We talk about life on the planet. Okay, we have to talk about Well, first of all, let me just stick with one subject at a time. We'll come back to that. But sticking with Oumuamua, they thought that if it was a comet, then it should have outgassed, but it did not do that. So they thought maybe it was this cosmic comet. Maybe it had already outgassed all the material that could outgas from it, leaving the central part, which was only rock that had formed the original nucleus of the comet. But that's not true. As it turns out that it was very much like a needle-like asteroid, and it entered from a high angle and came down toward our solar system, and it came at literally a blistering 87.3 kilometers per second. What's that, like 190,000 something miles an hour? That's really fast. So first of all, we saw it on its way out. We didn't catch it when it was coming in. Okay, it just was like an accidental discovery. We'd have no warning if this was going to strike the Earth. It would hit us and would say, "What was that?" It moved in and out, and it was gone within just a short time. So basically what I did was I took a cylinder volume, which is pi r squared, the area of a circle, times the height of the cylinder, and I set that equal to the volume of a sphere. Okay, and that gave me the ability to solve for a radius of the actual sphere. And I came up with something that was like 227 meters in diameter, and that would be let's say iron or whatever. And if it was going 196,000 miles an hour, or that 87.3 kilometers per second, okay, what would have happened if it hit the Earth? Well, in my program, I calculate different types of things, apparent size of the crater, actual size of the crater, angle of impact, all that stuff. Well, I assumed for these discussions it was mostly iron. All right, so they're pretty dense. And with less densities, you'd get different results, but they would be less. This is the worst case. So the first case was if Oumuamua just came right down and hit straight on the Earth. Okay, and again, we're just sort of assuming a sphere, and just get a rough order of magnitude. So if it comes down straight down at 90 degrees, it would actually have hit the Earth with the energy of 4.5 megatons. All right. In other words, it would hit with like a 4.5 megaton nuclear warhead wherever it hit. And then the crater diameter would have been 5.5 miles initially, okay, but then it would settle to 4.4 miles once everything sloshed back, and that's 7,100 meters or so. And it would be a depth of 1.1 miles. That's how deep the crater would be. So imagine that if it hit the ocean, go right to the bottom and make a 1.1 or a 1 mile deep crater on the bottom of the ocean. Tsunamis pretty much worldwide, probably. And that's 8,800 meter depth, in the crater, and the debris would have gone out 9.5 miles in every direction, So that's if it hit straight on. Now, if it hit like an angle of like 20 degrees, well, the energy expenditure is still going to be 4.5 megatons. It's just going to be distributed through an ellipse in the atmosphere, and a bigger ellipse, I should say, in the atmosphere as it's entering the Earth's atmosphere and starting to, reach that maximum aerodynamic pressure. And that crater would be about 3.8 miles in diameter, which is 4,900 meters in diameter. It's incredible and its depth would be more than 3/4 of a mile. Now, you just imagine walking up to a crater that's 1.1 miles deep, okay, or 3/4 of a mile deep. This is a Oumuamua, something that's only like a couple thousand feet, or 1,000 feet in length, But the energy it has from the motions, that's the key, see? And its debris would spread out about 6.6 miles. And again, this assumes a composition of iron, and the numbers are revised downward if you go to stony compositions or dense stone. But Oumuamua would have spelled disaster for our planet. Now, it wouldn't have been as bad as a major extinction event, but certainly would have put a dent in our world and the way we live, right? Think about our infrastructure. Where would we get our fruits and vegetables? And the ability to get them from place to place, that would change. How about the electronic infrastructure, the internet, okay, and your smartphones? Well, that stuff would all be down, okay? Everything would be disrupted. If the internet goes down for an hour, you go nuts. What if it was down for weeks? Because a lot of it was destroyed. Can you imagine that? Now, for reference, the Chicxulub impactor was 7 to 50 miles in diameter, so 11 to 81 kilometers in diameter. And we know that object, what that did to the planet. Now, there was no infrastructure dependent on it, but can you imagine that? So we'll talk more about these impactors and other things that can happen when we get back. This is Mark D'Antonio on SkyTer Radio with Daryl and Amanda. We'll see you in a bit.
Ready, Knoxville, Tennessee. The Alien Expo is coming August 17th and 18th at the Knoxville Convention Center. Prominent top-level UFO researchers and experiencers from around the world present Real X-Files, encounters with UFOs, true alien abduction accounts, contact with extraterrestrial beings. See America's most high-profile contactee, Travis Walton. Hear about bases on the moon from former NASA aerospace engineer Ken Johnson, MUFON abduction expert and niece to Betty and Barney Hill, Kathleen Martin, UFO truth embargo and disclosure advocate Stephen Bassett. Come and enjoy a full weekend of presentations, music, vendors, meet and greets, book signings and autographs, cosplay, alien costume contests, and more. Day passes, weekend passes, and VIP passes available now. The first annual Alien Expo, powered by Mysterious Radio. Make contact at alienexpo.com.
Feeling sluggish, bloated, gassy, and, want some relief? Try Life Change Tea at getthetea.com. Our unique blend of all natural herbs go to work on your digestive tract, giving you So before you try our super strength formula. It does a great job removing intruders that jack you up. Thousands of people use Life Change Tea every month, so try it because you're gonna love the way you feel. And here's a little pick-me-up. Order now and receive 10% off your first order by entering in 10 today in the coupon code. That's 10 today in the coupon code. Go to getthetea.com. That's getthetea.com. Enter 10 today in the coupon code for your 10% discount. Wow, feeling good never felt so good. Get some tea love at getthetea.com. Changing America one tea bag at a time.
Hey, is that a new music app?
Yeah, check it out. Surfer Music Discovery. It links to thousands of online stations, but the twist is you see the song names and artists that are now playing live.
That's different. No guessing. Looks like a waterfall of music.
So many formats. Rock, oldies, country, R&B, jazz, and a whole lot more.
How's that spelled?
Surfer. S-U-R-F-R.
Is it expensive?
It's free. No need to sign up or sign in.
Get the Surfer Music app free from Google Play or the App Store.
Are you intrigued by Paranormal Talk Radio? You'll love the new Paranormal Radio app from TalkStream Live. You'll find a great selection of talk shows covering UFOs, ghosts, strange phenomena, and much more. Download the Paranormal Radio app now and start listening to the very best in paranormal talk entertainment, including the network you're listening to right now, the Paranormal Radio app. Free in Google Play and the iOS App Store.
Your alternative talk radio contact, The Planet, KGRAradio.com.
Hey, everybody. Welcome back to Skytour Radio. Mark D'Antonio here with Amanda and Daryl. We're happy to be with you, and we're talking about planet killers tonight and the types of things that can destroy a planet. We've talked about that Chicxulub impact that killed the dinosaurs 65 million years ago. We've talked about flood basalts last week and a little bit this week in the Siberian traps, which may have caused the Permian extinction, which killed almost 98% of life on this planet. And tonight we're talking about other types of impacts from asteroids and other potential impactors. Now, we've also had some really wonderful questions, and I kind of just like the questions to flow. And one that came in a little while ago before the break, and I'm sure he forgot that, or he thought I forgot about it, came from Libertas. He said, can we talk about the Drake equation? Yeah, the Drake equation is an interesting equation. When I was getting my degree in astronomy, we had yet to find any planets around other stars. There were candidates. There were a few. But the first one wasn't confirmed until after I got my degree. And I've told this story before, and that is when I went into the director of the observatory and I said to him, I believe it's a populated universe. Well, that eventually became the title of my book, The Populated Universe, which talks about my conviction that life in the universe is the rule, not the exception. And he basically said to me that we don't know that. We don't have any idea. And I said, well, look at the symmetry of our bodies, okay? There's symmetry in every living thing on this planet. It's all carbon-based. Carbon's the most versatile element in the entire periodic table. Don't you think this would have been repeated elsewhere? And he was like, well, maybe, but we don't have any evidence of it. I said, but do you need evidence yet? And he goes, well, we don't even know if there's any other planets out there. I went, oh, okay, well, whatever. I said, I just think it's a populated universe. And he said, look, get back in the observatory. You've heard this before. Get back in the observatory and leave Captain Kirk to us. Okay. We all laughed. I went back to work. Well, anyway, when we did finally confirm the first candidate, I happened to be in the area, and I came into his office, and I just peeked in. He was on the phone, and he covers up the phone. He looks at me, and he goes, it was only one planet.
It was Beta Pictoris, wasn't it?
I forget if it was Beta Pictoris or it was
Fomalhaut, one or the other, I think.
Yeah, I can't remember. Okay, it was 1989 when this occurred. I think. So 88 or 89. Which I just dated myself here. That doesn't matter. Astronomy is for all ages. So basically, since then, the Drake equation, which was a formulation by Frank Drake, and that was like 1959.
Right.
Right? I think that was back then. And basically, the whole point was that Frank Drake thought that we could calculate the number of potential planets, number of civilizations, say, within our galaxy, with which we could communicate. And that was his big N, the big number N, the letter N. And it depended on a lot of things. It depended on, for instance, the average rate of star formation in our galaxy. Okay, we have a pretty good handle about that now. The fraction of those stars that have planets. Well, when Frank Drake created his equation, we didn't have any idea about that. Now we do. The average number of planets that can potentially support life, per star that has planets. So if you have a star that has planets, how many of those could support life? Well, we know one in this solar system, and that was the only one we knew. Now we know that, say, TRAPPIST-1, for instance, has 3 that are in what we would call the habitable zone. 3. And we see a lot of that being repeated. So these numbers are changing, as you can tell. And then there was another factor that was the fraction of planets with life that actually could go on to develop intelligence. Okay, and that has there's a lot of subtexts there. For instance, could they pass their nuclear era? Because if they're going to leave the planet, they're going to have to develop ways to harness energy. I don't think they're going to jump into very, very high efficiency solar panels right off the bat. I think they're going to go with what the planet provides, and what the planet provides is wood, coal, And this is probably throughout the universe. I think trees are a common construct. I don't think we're the only ones that have trees. So they would provide coal and probably oil, and I'm sure that a civilization would probably find that. And so that they would go through a fossil fuel phase as well. Ooh, that's interesting. Fossil fuel phase. Wow. And then they would go to a nuclear era when they wanted to move ahead. Some of them would then develop bombs because, of course, I would expect, because they would probably have broken up into factions like we have on this planet. We have countries. We have different ideologies. The bigger the planet, the more factions, most likely. So we want to say that, that fraction that would develop intelligence is still an unknown to us. We don't know that answer. Then there's the fraction of civilizations that develop a technology that releases some sign to us that it's there. So like our Voyager with a little record on it that shows the human race and the directions to our home. That's a very simplified approach. I mean, we're talking about the fraction of civilizations that develop some kind of technology that we would see. For instance, pollutants in an atmosphere. How about that? Now, I've said before, and I said this when I was doing my talks. I did a speaking tour out in Arizona a couple weeks ago. And one thing I mentioned was oxygen in the atmosphere of our planet is the biggest single example of a giant flare being lit over our planet saying, look at us, we're here. Now, why? Why is that? And it's because oxygen doesn't want to be in the atmosphere. Oxygen will get out of an atmosphere almost as quickly as it's made. It happened on other worlds here in our own solar system. It happened on Mars, okay? And that was because the magnetic field was destroyed. So the H2O, which has the O as oxygen, was photodisassociated by the ultraviolet light, which would break the hydrogen and oxygen away from each other. The hydrogen would escape to space. The oxygen goes down to the ground. It bonds with an iron compound in the soils because iron makes up a lot of the soil. And that's why Mars is red. It rusted. That's right. It rusted. So that said, at least two people in the audience went, oh, that's cool. It's amazing. It's right in front of us, and we sometimes don't even see it, right? So any civilization that develops intelligent life probably, I'm guessing, is going to be a carbon-based life and thus need oxygen to live. Now, you might say, well, what about silicon-based life? Silicon is an element that is versatile, but not nearly as versatile as carbon. The carbon atom is the single most active element in the entire periodic table. It can bond with millions of things and create hundreds of thousands, if not millions, of compounds. Silicon can't come close, but it's second, but it's not even close. So that means that carbon-based life is probably going to be selected for continuance in the universe and therefore be a template throughout the universe. So I'm pretty sure that would be amazing, right? To find life that is other carbon-based life, and that will happen, So that said, the other thing too is in the Drake equation is the length of time at which a civilization is in existence to be able to give off some type of signs of their existence. Okay, so we have the average rate of star formation. We have the fraction of stars that have planets. We have the number of planets that can potentially support life per star that have planets. We have the average number of planets that can it's the same one. The fraction of planets that could support life that actually develop life at some point. Okay, we have the fraction of planets that go on to develop intelligent life, and we have the fraction of civilizations that can actually create some type of sign that we might see, whether for purpose or inadvertently. All right, and then the last one is the length of time at which a civilization will be releasing such information to the universe, because they may evolve past it, or they might die off. Something might happen. So all those numbers together, taken together, they're all multiplied to each other, gives us a value that will tell us something less than 1, about how many civilizations might be in the universe. What we really know now is the fraction of stars that have planets, and we have a really good idea about that. And we also have a good idea for the average number of planets that could potentially support life. But we have to figure out if they have an atmosphere. And that's what James Webb will be about. See, so little by little, we're filling in the Drake equation. But an Italian team has already done some of this. And the Italian team has actually figured out that using some of the newer data, we might be looking at about 25 million other Earths in our galaxy. And that's very, very conservative. They think it's much, much more. I've heard estimates of up as high as 40 billion. And that's if we have about 400 billion stars. The idea is about 10% of the stars in our galaxy might host an Earth-like habitable world. And that's probably a little bit more ambitious, but it'll be somewhere between that and the lowest estimate, I think. It's certainly not zero. Can't be. We're here. Anyway.
Speaking of people that are here.
Yes, we have a caller.
We do have a caller.
Awesome. Shall we answer the call?
I think it would only be prudent.
Okay, let's prudently answer the call. All right, here we go. Hello, you're on the air. This is Mark. Who's this?
Hello, Mark. This is Ronald from Minnesota.
Ronald from
Minnesota.
Ronald. Hey, you're the guy.
Hi, Amanda. Hi, Daryl. And
Ronald, you're the guy we think should stop trying to. What did you say, Daryl? He has to start looking for meteors and stop.
Right.
I guess I do have a metal detector. I need to get out and test it out, and especially in all these cornfields that I have over here.
I was wondering, could he find gold in a meteor?
You can.
It's possible.
There you go.
Yeah.
Gold settles to the lowest point, and lead is gold is 19 times heavier than water. Lead is about 12 times heavier than water, a little bit lighter than gold, but they both settle on the lowest point, wherever that might be. Okay.
Yeah,
but
meteors typically are broken chunks of bigger objects, so they could be anywhere in a meteor.
So I was going to say marvelous Mark, right? Amazing Amanda, and I was trying to think of a word for Daryl.
Dynamic.
Daryl.
No.
Dynamic Daryl. Oh, that's good. Dynamic Daryl. Okay, there you go.
Dazzling is good.
Okay.
No.
I couldn't think of the word for Daryl.
I'm twirling my mustache. Think of dastardly, okay?
Think dastardly and the wacky racers.
The question I had
Go
is
ahead,
the gold that we have on planet Earth was primarily here from the time the planet was created, if I remember correctly.
You do.
In most thinking about how the gold got here on planet Earth. And so now what we're finding today basically is gold has worked its way up to the surface. Now there's been some pretty large pieces of gold found, 36 ounce nugget they found one time in I think Australia, was it, or was it Africa someplace?
Ronald, here in Colorado, they found one gold nugget that weighed, I think, 110 pounds. It's called Tom's Baby.
Yeah. There you go.
It was found near Breckenridge, Colorado. I used to live there.
Yeah. So now how does that gold form so darn big? I would love to find one like that.
I wish I could tell you the dynamics in Earth science that could cause that, but the fact of the matter is that it was probably back when the Earth was formed. The Earth was molten, obviously, and because of that process I've mentioned before called differentiation, the heaviest items would tend to migrate toward the core of the Earth, including the radioactive elements as well. So a lot of the heat from our planet, for instance, is generated by the radioactive elements that are in the center, as well as the initial heat of formation from the beginning. And the rock is a very good thermal insulator. It can hold on to heat for a long time. But the gold also was settling down there. So you might say, well, why do we have gold in our lithosphere, in the crust? And the answer to that question is because Earth has been recycling its crust and has been struck by objects that have mixed up this material a number of times. It's not a perfect mix. It's not a perfect differentiation. So we do have veins of this heavier material, which stands to reason that's why it became what's valuable, because of the fact that it's rarer. It's not common to find gold lying around on the rocks.
Exactly.
It's much more common to find it in a vein, a seam of area underground where the gold actually managed to when it was a molten collection, it managed to cool there because it got mixed into that part of the crust.
Yeah, that's one of the clues we look for in California with the quartz vein, with the quartz line. You can follow the quartz line, and you can find gold a lot of times next to the quartz.
Ronald, I used to work in the largest underground mine in North America. Now, gold was not our business, but there was gold there. I used to work at a place called the Climax Mine, which sits up on top of Fremont Pass here in Colorado. The ores we would find, they tended to follow fault lines in the mountains. You could call them earthquake faults if you want, or veins, or, seams, as Mark said. Some of the stuff was in solution. It came up in hot water and crystallized when it cooled off. The gold, I suspect, would have been molten at the time. But again, the molten rock, the magma, the whatever, followed those fault lines up and helped populate the veins in the mine. Mm-hmm. And though we were not a gold mine, occasionally the real miners would strike gold. And the company said, well, we're not in the gold business. And they would send in a management team who would come in and build concrete forms and wall off that gold. Okay, because the geologists, the mining engineers, they would very carefully lay out paths for tunnels, drifts, and such that the miners were supposed to follow as they developed the mine, okay? And when miners, being the way miners are, would hit gold, well, all of a sudden those carefully laid plans of the mining engineers would start veering off to one side because the miners started following the gold instead of the plan.
Wow, this sounds like we need to have another talk about this. But anyway.
Maybe you need to become a miner, Ronald.
There you go. What do you mean? I am already. All right. Thank you very much. Thank you for the show, Mark, and thank you, Producer Bill, for taking the call, and thank you, Amanda, for being here today. And Daryl, thank you
for sitting back and listening. Thank you. Thank you for the call, Ronald.
For all your answers.
Thanks, Ronald.
Yep. All right. Bye.
Good night, bud.
See you, Ronald.
So that was a molybdenum mine, the Climax mine, wasn't it?
It is. It was. Well, it still is. Yeah.
Yeah, and it was closed for a while, huh? Something happened? What happened there? It was closed.
Oh, prices collapsed. The market fell flat, and they closed the mine. That place employed 3,000 people when I was there, and they shut it down back in 1982. It lay fallow for a long time, and they opened it again some years ago. But this is probably not the time or place. I could tell you stories about working in the mine that would curl the hair on the back of your head. But yeah, it used to be an underground mine, and it's totally an open pit now. They closed the underground, which is where I worked, and just let it all flood out. Yeah. But the Climax mine was the second largest consumer of electricity in the state of Colorado back in the good old days.
Wow.
Late 70s, early 80s.
That's impressive.
There was a huge, basically a big city underground.
Yeah.
Like 170 miles of tunnels, I believe, if I remember correctly.
Well, think about this.
Could an asteroid impact create a mine?
It's funny you're going to say I knew she was going to ask that question.
Did you?
I did.
Or did I anticipate your next comment?
You're right. I don't know. I thought that I thought your
maybe
question
I read your mind.
I thought your question was going to be basically, could an asteroid impact bring minerals that are valuable to the Earth that could then be mined from the asteroid impact site?
Okay.
That's what I thought you were going to
getting there. I was close.
I think you were correct.
Well,
who knows? Maybe that has happened already. We weren't aware of it because, as rock strata, goes on this planet. When stuff hits our planet, most times it's molten. It will become molten, and then when it cools, then it becomes part of the rock strata it's in. And who knows how large impacts could be distributed through our crust. So it's possible that
I believe there are some iron mines that they attribute the ore to, like an asteroid impact.
Yeah, exactly. Now here's the thing, last week when we talked about these flood basalts as being the worst extinction event generator in the Earth's history, what about this? Okay, what if one of those flood basalts happened today? What if we had another event like the Siberian Traps event, where we had a 100-year-long volcanic eruption that covered thousands of square miles every day, all day long? Can you imagine? There would be so much gas being thrown off by that, from carbon dioxide to hydrogen sulfide to obviously water vapor and steam. That would actually be a disaster for that local economy for sure. We would actually we wouldn't be able to cope with it actually, and we didn't discuss the coping mechanism for doing this now. Like if we had a flood basalt, if that happened here on Earth now, we'd have to figure out how to move entire regions of millions of people to new homes, millions of people to new homes, because they would lose it. We'd have to figure out how to counter the increase in hydrogen sulfide and other gases that would cause unprecedented acid rain. We have to worry about the heating up of the oceans and the subsequent die-off of massive numbers of creatures. If you recall, oxygen doesn't really like to stay in warmer water too much. And the trials would be endless for us, trying to get through it. It would actually cause a domino effect. One ecosystem would fall and bring down 4 more right behind it. So the question is, how long would we survive? And how could we survive? What would we have to do to survive that? Well, our marine ecosystems would be very, very sensitive. So we might say, well, let's generate oxygen somehow and infuse it into select marine colonies to try and preserve some marine colonies. Let's cool vast tracts of ocean water somehow with a cooling mechanism of some kind that we have yet to invent. We'd have to stop the potential warming of like 27 degrees from carbon dioxide and methane into the atmosphere. How do we stop that? And we're facing cries of tragedy now when we're talking about raising the Earth's temperature by a degree. And we're talking about 27 degrees, from the Permian period. And if this were to happen again, it would happen again. So if you think if you think we have an effect on the world, just think of how that one single flood basalt event on the scale of the Siberian Traps eruption 520 plus million years ago. Think how that influenced all of the life on this planet, and think about how that a flood basalt that happens here, if it were to happen again, would hurt the planet. Remember, the Yellowstone supervolcano eruption doesn't even compare on orders of magnitude. The Siberian Traps flood basalts were far higher in their devastation than even the Yellowstone volcano. Even though the Yellowstone supervolcano dropped over 9 feet of ash in Nebraska, okay, that was just a little puff compared to the Permian period Siberian Traps eruptions. And when the first eruptions started occurring for like 100 years, the rest of the world didn't even know what had happened. Nothing much was happening there. It's when that carbon dioxide escaped from that lava cap, that organic compounds in the soils far outside that magma vent that was covered by now this cooled lava. That magma ended up percolating horizontally away. That's called a volcanic sill, if you recall, SILL. And it made many sills in Siberia. You can actually find them today. And these sills actually, when they reached those organic compounds in that, they actually released a lot of carbon dioxide that was trapped underground. And it followed and went into solution with the magma until it actually reached the edge of that lava cap. And that's when it came out, and we had gigatons, billions of tons of carbon dioxide going out into the atmosphere all at once. That must have been one heck of a sight to see this volcano. And anything near it would, of course, the life would have been extinguished immediately because the oxygen was going to be displaced by the carbon dioxide, and they would die. So if you saw it, you probably were going to die from it.
That's
Boy,
scary.
what a wonderful thought. However, we have a pretty good pulse on this stuff now, and even though you can stand in Yellowstone Basin right now, the Yellowstone Caldera actually, which is a few miles across, and beneath your feet, just 2 miles, is a 100-mile deep lava chamber. If that's frightening to you, then just think of the 600-mile lava chamber that was there that was at the Siberian Traps for that flood basalt eruption. I mean, that lava drained for 100 years and went on and off for over 300 years. So let's hope that doesn't happen again. But luckily, seismic work and all the stuff we do helps us see that we are on the straight and narrow, and we have a civilization that's going to head to the stars eventually, with a few false starts. Okay. And we'll talk about in coming shows, we're going to talk about some of the new technologies that we're going to be using to reach places like Mars and even farther beyond. And we'll keep some of those close to our vest right now until we can solidify the exact topics. But it's going to be wonderful. Folks, on behalf of Daryl and Amanda, I'd like to thank you for joining us for Sky Tour Radio tonight. Tonight after the show, if it's clear, I think we're going to do a Sky Tour live stream. And I will be back on the air with you in the live stream if it's clear out there. Anyway, I want to thank you guys for joining us. Thank you, Daryl. Thank you, Amanda.
Thank you.
And
thank you guys for all the great questions.
Exactly. I was just about to say, because Amanda reads minds. Thank you for all the wonderful questions in the chat.
Makes it so much more enjoyable.
It does. It makes it so easy to do the show, and because we answer what you want to hear, and that's the kind of thing that I think is important. Anyway,
it sparks my mind for questions too.
Yeah, that's right. Yeah. Okay, folks. You all have a good night, and remember, keep looking up.
Except while you're driving.
Night, everybody.